Hello, Algebra 2 for Mr. Fry. You're looking at today this scatter plots, infinite algebra, CUDA. I'm going to go through the odd ones for you. It's just kind of reviewing what you've been doing this week. It says state if there appears to be a positive correlation, negative correlation, or no correlation. When there is a correlation, identify the relationship as linear, quadratic, or exponential. So remember, linear is going to make a straight line. A quadratic is either going to be like a U shape or an N shaped kind of a curve. And all that goes by curve, I mean, it's like this or like this. And then this exponential is a curve too. I mean, it starts like real low and then shoots up high fast, or or it's coming down and then going, flat. So linear is just going to be a line, either increasing or decreasing. Okay. So right here you have no correlation. I mean, I can't figure out any line that fits as the best fit for those points. This is going to be positive and it's quadratic. It's positive, but it starts to drop. And it kind of gives, it doesn't go flat or anything, but it kind of gives the impression that it's going to, continue to go down like that. So quadratic on that one. Number 5, this is going to be positive correlation and it's linear. All you do is plot these points. 1,000 goes to 1,003, so 1,000, 1,003, all the way up to 10,005. 10,000 is to 5,200. So 10,000 on the x coordinates. Remember, these are your x's and these are your y's. Okay, this is supposed to be an x. All right, and so this 10,000 goes with the 5,200 for the y, and it's positive and it's linear. Number 7, for this one, you just had to pick a couple points. Pick 2 points. And in order to get the slope, so you have your y2 and your y1, your x2 and your x1. So you could pick any 2 points and just so say you pick this one and maybe you pick this one here. So this would be your your y2 minus your y1, your x2 minus your x1, and then you figure out your slope. So you get the slope, you put that in there, and then you pick any of those points. You could pick the points you already picked, and just pick one point, and you put your y in there. So 640 here, and then you put your 41 here, and it comes out like this. It could be a little bit different because you could pick different points, but it should be somewhat close to this. That's what I have there for you. So there's the odd ones. Try the evens on your own. Make mistakes. That's okay. We learn from them. And then for the odds here, write the slope-intercept form of the equation of the line through the given point with the given slope. So you're given the slope and you're given the point. So how you do that is, I plug in the slope and I'm given a y point and I'm given an x point. And then you just start solving. I multiplied 7 halves in for both of these. And then I added 5, to this side. This could be 5 halves. You could have 5 over 2 over here also. Okay. For number 3, find the slope of the line that passes through each point. So you're going to use the slope formula. Take your second y minus your first y, your second x minus your first x. Go ahead and do that, and you should get 8 over 7. Where did I get those? Once again, this is my first x, this is my second x. So I put my little 2's there, my little 1. This is my first y, this is my second y. Okay. For number 5, write the slope-intercept form of the equation of each line. So I just had to get y by itself on one side, in other words, because remember, slope-intercept form is going to be y equals mx plus b, where m is the slope and b is the y-intercept, or that constant that's out there. So I do it right here for you. I subtracted, what did I subtract? Oh, I subtracted the 8x from both sides, and I end up with it over here. And then I divide both sides by 5, and I get a negative 8 over 5x plus 7. For number 7, I'm to write the standard form of each equation of a line. Remember, standard form is, some number with x plus some number with y, and that's going to equal, some constant. So this one just, when I do that, and I show the work over here, I put the constants together, so I add a 2 to both sides, and so I get 2, because I have a minus 2, so I just add this 2 to both sides to move it over here to get the y by itself. There was no x, so there is no x. 0x plus 1y is going to equal 2. So in other words, it's just y equals 2. So for number 9, find the value of x or y so that the line through the points has the given slope. So here we have to plug this into my slope. So this is my slope. So I'm going to have this y minus this y. So this would be my first y. And this x minus this x. So I just used, this formula up here once again. And it's set to 0. So when you start solving it, you figure out that, well, y has got to equal 19, because 19 minus 19 would give you 0, divided by negative 18 would give you the 0 slope. And then last but not least, number 11, I have the standard form of equation of a line is described, and it's perpendicular to this. So I know that the slope that's perpendicular to this line, that's going to be for this one, is going to be the opposite inverse. So it's going to be a negative 2/3. So I use my point slope formula, and my new slope is negative 2/3. And then I have my y, which is a minus a negative 3, so it becomes plus 3. And then I subtract my x, which is a 3. So then I just work the problem out, and I end up getting y equals negative 2/3 x minus 1. Hopefully this helps, and good luck on all those evens.